Okay, let's talk problem setup. Hopefully you've taken a few minutes to make some initial guesses about your strategy. If you've already gone all the way through and gotten an answer that you're happy with, congratulations, because this is going to be a tricky problem. It's one of those problems where the individual parts will seem straightforward, but lining up your thoughts and following the thought process all the way through the end can be challenging. So again, this problem refers back to a problem that was covered in our serial dilution review. And I would encourage you to go back and take a look at that problem and the thought process there and the math before diving into this problem. But the key thing here is, once again, this is a serial dilution problem, but the propagation of error is a little more challenging because, unlike our previous serial dilution problem with propagation of error, in this problem, we are starting out with a weight percent and we're converting the final concentration to molarity. And that conversion from weight percent to molarity for the stock solution before we employ M1V1 equals M2V2 actually is significant for propagation of error because both the original concentration and the density of the solution, we can now see the absolute errors associated with those. As a reminder, the initial conversion will also involve a conversion using the molar mass of ammonia, but in most problems and in most lab work, unless you're told otherwise, we can assume that the error in any molar mass is negligible because that's extremely well defined and extremely small compared to basic laboratory measurements such as measuring a volume or measuring a density. All right, so our first step has to be to understand the math of how we got to the answers. That's what we'll discuss here. We know based on our previous calculation that the final ammonia solution, the dilute ammonia solution, will have a molarity of 0.250 molar. Because we are using a conversion to get from a weight percent to a molarity, followed by M1V1 equals M2V2, we know that all the steps in the math that we're doing for this problem involve multiplication and division. Therefore, the error must propagate as relative error. And ultimately, the calculation is M1V1 divided by V2 gives us our dilute solution concentration. The step before that is we start with the weight percent of the original ammonia solution, and we must convert that to molarity when we use the formula here. Our total error then will still propagate as a percent error because we're only using multiplication and division steps, and the total percent error is going to be equal to the percent error in the stock solution molarity squared, which will be the challenge to determine in this problem, the percent error in the volume removed from the stock solution squared, percent error V1. We can define that pretty straightforwardly because we have the absolute error and we have the total volume, and the percent error in V2. There should be a squared there, but it appears to have dropped off this slide. I'll make sure it's back here for the next one. So our overall percent error is still going to be propagated in the usual way for multiplication and division. The challenge here is we can calculate this error and we can calculate this error in a pretty straightforward fashion. We need to be able to calculate this error to start the problem.